Okay, this is the third and final video for section 7.4 on area and arc length in polar coordinates. The arc length of a curve defined by a polar function. Let f be a function whose derivative is continuous on the interval, I have the inequality, alpha less than or equal to theta less than or equal to beta. The length of the graph r equals f of theta from theta equals alpha to theta equals beta is L equals the integral from alpha to beta, square root of f of theta squared plus f prime of theta squared and d theta, or it's equal to the integral from alpha to beta, square root of r squared plus dr d theta squared and then d theta. And the derivation of this is in your textbook in section 7.4. So let's go ahead and look at an application here. So we're going to find the arc length of 5 plus 5 cosine theta, that cardinoid there. And for theta between 0 and pi, I went ahead and provided a sketch of the cardinoid here. And so we're finding the upper half of the cardinoid. Okay, so from 0, and I will just sketch it all the way to the dimple. And so we're going to find that arc length. If you want to find the arc length of the entire thing, just double it. Okay. Alright, so the length is equal to the integral from alpha to beta, and then it's going to be the square root of r squared plus r prime squared. And when I say r prime, I mean dr d theta, and then d theta. R prime is equal to negative 5 sine of theta. Like previously when we've done with arc length, it is difficult to just pick a random function and say, okay, let's go ahead and find the arc length of that. Chances are you're going to run into a nasty integral that you'll probably need to use some sort of numerical methods or maybe a table. So we have to be careful in terms of which ones we actually want to try. And so this one we can integrate with conventional methods. We do have to use a little bit of a sneaky trick on it. Okay, so we have the integral from 0 to pi, and it's going to be 5 plus 5 cosine of theta squared, and then a negative 5 sine of theta squared, and all that under the square root, and then d theta. So it's going to be equal to the integral from 0 to pi, and then we have 25 plus 50 cosine of theta plus 25 cosine squared theta plus 25 sine squared theta, all of that under the radical d theta. Okay, so it's going to be equal to 0 to pi, integral from 0 to pi. Where did the 50 come from? Well, we have 25 plus 25 cosine squared theta plus 25 sine squared theta. So that's 25 plus 25 times cosine squared theta plus sine squared theta. And cosine squared plus sine squared, that's a Pythagorean identity, that's 1. So we have 25 plus 25 times 1. So that's where that 50 comes from. So we have 50. And then, so we've taken care of all of this, the 25 and then the 25 cosine squared plus 25 sine squared. So what's left is 50 cosine theta and 50. So factor out of 50, so we have 50 times the quantity 1 plus cosine of theta, d theta. We can take out the 50 out of the radical, so the square root of 50 would be the square root of 25 times the square root of 2, so that gives us 5 root 2. Integral from 0 to pi of 1 plus cosine of theta d theta. Here's where our trick comes into play. So we're going to use the power reducing formula. Cosine squared theta is equal to 1 half times 1 plus cosine of 2 theta. But we're going to get this and go backwards, okay? So what we're going to do in our integral is we're going to multiply by 2 and multiply by 1 half. That doesn't change anything. 1 plus the cosine of theta, all of that under the square root, d theta. Okay. So we have 5 root 2. And then I'm going to factor out the square root of 2. So we have 5 root 2 times the square root of 2. That's factored out. Integral from 0 to pi. Okay. And the 1 half 1 plus cosine theta will become cosine squared of theta over 2. So you're going to half the angle there. Oops, too far. All right, now we have a quantity squared under a square root. Cosine squared of theta over 2. The theta over 2 would be between 0 and pi over 2. The cosine is positive in quadrant 1, so the square and the square root would undo each other. Okay. All right, so let's just go ahead and write that down. Okay, so we had theta is between pi and 0, so then theta over 2 is in quadrant 1, and the cosine is positive in quadrant 1. Normally, if we were looking at the cosine squared of theta over 2, it's going to be equal to the absolute value of the cosine of theta over 2, and that's going to be dependent on where the angle theta is. If the angle theta is in quadrant 3 or quadrant 2, then the cosine is going to be negative, so it's going to affect things there. Anyway, so we're okay there. All right, so we got the square and the square root undoing each other. Okay, so we got 5 times the square root of 2 times the square root of 2, so that's going to be 5 times 2, which is 10. Integral from 0 to pi, cosine of theta over 2 d theta. And looks like I forgot my d theta. Let's sneak it in there. Oops. D theta. Okay. So we have 10 sine of theta over 2, and then it'll be divided by 1/2. Integral, and then evaluate from 0 to pi. It's going to give us 20 sine of pi over 2 minus the sine of 0 over 2. And so that's going to give us an arc length of 20. If you want to find the entire arc length here, just double it. And so the full arc length from 0 to 2 pi, it's going to be 40. Okay. Alrighty, that's it. And this will probably be our last video here for Cal 2. I might have a couple other ones that I might post, but we'll see you next time.